So what are the differences between a binary search tree and a MaxHeap or priority queue? The main difference are as follows, as you can see in this slide. The first thing is a binary search tree or a BST may or may not be a complete binary tree. However, the MaxHeap or a priority queue data structure must be a complete binary tree. That is, in a binary search tree, you really do not need to fill up the tree at a certain level, starting from left to right in this way. However, you must fill up the vertices of a tree at a particular level, starting from the left to right direction in case of a MaxHeap or priority queue. The second difference is its relation relation among its left parent, left child, and right child. So in a binary search tree, the relationship is like this. The left is always less than the parent, which is again less than the right. That means the maximum always appears in the right hand side, whereas the minimum appears in the left hand side, and parent stays in between. However, in a MaxHeap or priority queue, the parent is always greater than both of its left and right child. Now, there is no relation between the left and right siblings though. Left can be either greater than right or it can be less than right. The vice versa is also true. Right can be less than the left, or right can be greater than the left. So there is no relationship between the left and right siblings, but the parent vertex should be greater than both left and right. Now, what is the motivation of constructing a MaxHeap or a priority queue data structure? As I have told earlier, all the data structures have been proposed in order to make some kind of computational job efficient. You already have learned that a binary search tree with both these left less than parent less than right, this property can make the search of an item in a group of item efficient. On the other hand, the properties of a MaxHeap, that is its completeness and parent must be greater than left and right both, these two properties makes the sorting of all the items in a group of items very efficient. Now let us try to analyze some example binary search tree and MaxHeap to clarify the concept more. So both the trees in the left hand side, that is this one as well as this tree, both of them are an example of binary search tree because it follows this left less than parent less than right relationship, assuming alphabetically earlier nodes means it is smaller. On the other hand, the tree in the right hand side is basically a MaxHeap because here it follows both the properties like like parent is always greater than left and right, so at every level. So for example, Z is greater than both P and H. Also, P is greater than its child A. So this property number 2 holds true. On the other hand, this tree is complete. That is, there is no empty spot in the left hand side, whereas some right vertex spot is filled up. That thing never happened. So the leftmost side is filled up and then there is nothing actually in this tree. So this is an example of max heap. But what about this example? Is it a max heap? Well, if you look at this node, the property number 2, that is parent should be greater than left and right both, that is holding true always. For example, Z is greater than P and H. Again, P is greater than its child A. But what about the property number 1? Is the tree complete? Well, no, it is not complete. Why? Because the right child of P is filled up, whereas the left child of P still remains empty. So that cannot happen in a MaxHeap or priority queue data structure. So since this tree is not complete, this is not a MaxHeap. So in the next few videos, we are going to understand different operations of MaxHeap.